All right, Unit 9, Section 4, here we go, regular polygon area. So we're not going to build the formula here in the video. We will go through this together in class. So I'm just going to jump right down to explaining the formula. And first of all, what an apothem is. So we'll start by defining that. We call an apothem the distance from the center of a regular polygon to any, you usually see it to the bottom, but to any of its sides. And that is, just a little note for you, the perpendicular distance. So that means it forms that right angle there. So we would call that thing the apothem. All right, so the area of a regular polygon is going to involve the apothem, of course. So to find the area, you're going to take a 1/2, and then we're going to take A, which is our apothem measure, times P, the perimeter. So I'll write a little note. A is the apothem. P is the perimeter of the object. So you're going to have to find the perimeter, you're going to have to find the measure of the apothem. Now, if it was just given to you like that, of course, it would be pretty easy. You're probably going to have to do figuring to calculate the perimeter no matter what. But if the apothem's given to you, it's pretty straightforward. But that's where a lot of our work is going to lie. So let's take a look at our first example. Calculate the area. So we need two things. We need A, the apothem, and we need P, the perimeter. So I'm given one edge of this figure, this regular pentagon is what you'd call this. One edge is 10, so I could quickly find the perimeter by adding up 10 and 10 and 10 and 10, and I get 50. So I have that part done. But the problem is I don't know the apothem. So just a reminder, that is the perpendicular distance from the center to any side. Now, like I said, normally it's just drawn to the bottom. Doesn't really matter. No. I'm just going to continue that pattern, though, and keep drawing it to the bottom. So what we're going to do is we're going to make a right triangle, because the apothem is the perpendicular distance, which means I have that right angle. Now, I know the whole side here is 10, right? So if I split that in half, that means that is 5. Okay, so far, not too bad. We're trying to find A, our apothem. Now, here's where things can get a little tricky. You're going to have to bring back those trig ratios we talked about a couple of units ago. And you're going to have to use the interior angle measurements we talked about a couple sections ago. So we can figure out the measure of just one interior angle of this regular pentagon, because they're all the same. So if we find one, we found them all. So we can take n minus 2 times 180 will tell us the whole measure of the interior. But if I divide that by n, again, I will get one particular angle. So in our case, we have a 5-sided figure, so that's n, times 180 divided by 5. So you can type that into your calculator. 5 minus 2 is 3. So 3 times 180. Well, there we go. Is 540. If you divide that by 5, each interior angle is 108 degrees. So let me try to help you visualize this. So this whole angle here is 108 degrees. That means this whole angle here is 108 degrees. But by making my right triangle, what I'm doing is I am cutting that angle in half. So half of our 108 degrees is 54 degrees. Okay, so half of our angle is 54 degrees. Now what I can do is use a trig function to relate what is going to be the opposite and adjacent sides. And hopefully you remember the whole SOHCAHTOA thing. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So this is going to be the key here to a lot of these types of problems. SOHCAHTOA. And tangent, you will see, relates the opposite and adjacent sides. So that is our trig function of choice. And all of this, again, is to find the apothem, because I need that times the perimeter times 1/2 in order to find the area. So you can see how these are going to get very complicated. So to set this up, we'll take tangent of our angle, 54 degrees, equals the opposite side over the adjacent side. Okay, and then you want to solve for your variables. So we multiply both sides by 5. Those 5's cancel, so we have 5 times tangent of 54 degrees equals A. Once your variable is by itself, we need to hop over to the calculator and figure out what 5 times tangent of 54 degrees is. Suppose it helps if you have the trig function in there. Okay, you hit enter, you get some gross decimal, we'll round to the nearest hundredth, so 2 decimal places, so 6.88. So A equals 6.88. So now all of that work just to find the area. So we take 1/2 times 6.88 times our perimeter 50. And again, you can type that into your calculator. So go 0.5 times 6.88 times 50, and the area of that regular pentagon is 172. Make sure I get my label here. 172, it says centimeters, so it goes centimeters squared. So these can go from pretty basic if you're given your perimeter and your apothem to pretty difficult if you have to find either piece of information. So try one more here. Calculate the area. So now I'm not given my perimeter and I'm not given my little a, the apothem. So that makes things kind of difficult here. But again, the nice thing is it's a regular pentagon. We just did all the work here to figure out the important information for a regular pentagon, like the angles. So if I make my right triangle, again, I have to draw the apothem in there. So I got to find A. I need to find a side length. So I need to know this whole side. But what I could do is find, I'll call it X, and then just double it to get the whole side. Because we did the work already, we know that one angle of these right triangles, well, one whole angle is 108. So the whole thing's 108, but half of that would be 54. So again, we can use trig. Let's find A, the apothem, first, and then we'll go back and we'll find X, the base of this triangle, and then we'll double it to find one side, and then we'll have to multiply it by 5 to find the perimeter. So again, we're looking at SOHCAHTOA. So I want to find A, so I'm looking for a trig function that relates the opposite side and the hypotenuse. And right here it is, sine. So our setup's going to be sine of our angle, 54, equals the opposite side A over the hypotenuse, 20. And just like before, you have to get your variable by itself. So we'll multiply by 20. So we have 20 times sine of 54 degrees equals A. Type that into your calculator. 20 times sine of 54 degrees is 16.18. So there we go, we got that. Now we need to find X, and then we're going to have to double it because that X plus another X will give us the whole side. And then we have to figure out the perimeter of the whole regular pentagon. So looking at X here, I'm looking at another trig function that relates the adjacent side and the hypotenuse. And hopefully looking up here, you're seeing, hey, cosine looks like the answer. So we would say cosine of our angle equals the adjacent side, which I just called x. You could have called it anything you want. Anytime you don't know what it is, though, use a variable, please. Over the hypotenuse, which is 20. So same thing, get our variable by itself by multiplying both sides by 20. So what that's going to do is tell us this distance right here. From there to there. We have to double it to find the whole side. So 20 times cosine of 54. Cosine of 54 is 11.76 if you round appropriately to the nearest hundredth. So x equals 11.76. So again, that's just this distance here. I need to double it. So 2 times x. So 2 times x would equal, take 11.76 times 2. Oh man, let's try that again. 11.76 times 2, and we get 23.52. So that means one side is 23.52 centimeters. So to find the perimeter, you can just add up 5 of those, or you could just multiply by 5. So we'll take 23.52 times 5. And there's the perimeter, 117.6. So our perimeter is 117.6. So after all that work, we can finally find the area. So you take 1/2 times the apothem, which was 16.818, times the whole perimeter, which was 117.6. So 0.5 times 16.18 times 117.6, and we get 951.38 centimeters squared. 951.38 centimeters squared. So a lot of work, but we'll be spending a couple days on this, basically a whole week on doing problems like this. But that takes care of section 9.4.